The question here says that write enough expressions to find VO. There is no credit for finding the exact value of VO. So we may not be, we are not required to basically solve it. We know this node is at 5 volts. All these resistors, let us assume them to be resistors in ohms or kilo ohms, whatever they are, or maybe they may be labels only, but let us try to solve it from known things. So we have this at 0 volt, we know this is at 0 volt. Whatever this is, let us label it as V plus. Then this V minus, because of ideal op-amp characteristics, we know that V plus is equal to V minus. Okay, let us have a better label. Let us say this is V1. So this is V1 and this is V1 as well. Let us label this node as well. Let us say this is V2. This is V1. This is 0 volts, 5 volt. This is VO. So everything is probably labeled now. Let us come up with a set of equations. As many equations there are unknowns for us to be able to find VO. So let us apply NVA at this V2. V2 minus 5 over 4 plus V2 minus 0 over 6 plus V2 minus V1 over 2 is equal to 0. How many branches are there? 3 branches. So there must be 3 terms in this NVA equation or KCL equation. How many unknowns are there in this equation? 2, V1 and V2. So we need another equation. So let us write this equation at this node V1. And this node voltage is V1. V1 minus, because this is open, I have therefore not made this a node, because V1, this 2 and 3 are in series and this is 0. So V1 minus 0 over 2 plus 3 plus no current can flow here because of ideal op-amp characteristics. So there are only 2 branches, V1 minus VO over 8 is equal to 0. How many unknowns in total? 3 unknowns, V1, V2, VO. So we need another equation. And from where can we come up with this equation? We can use this node. This voltage is also V1. So let us write equation here. V1 minus V2 over 2 plus V1 minus 0 over 8 equal to 0. Now these are 3 independent equations, and solving them can yield the value of VO, and that is what is required here.